Accuracy and precision. We're talking about how well we can measure things and how well we know we've done a measurement. Those two things, accuracy and precision, are important, and they do not mean the same thing. In everyday language, sometimes they're used that way, but no, they're actually very different. And again, words count, terminology counts here. So, what is it? Accuracy. Accuracy is how close do we actually get to the true value. If I measure the length of a table, there is an honest to goodness true answer. It is a certain length. Now, I might get close to it, I might not. I might be high, I might be lower, I might be dead on, right? Kind of thing. That's what we mean by accuracy. How close do we get to the true actual value? Right? Precision is something else. Precision is the repeatability of my measurement. Okay? How precise a data set is. And by repeatability, maybe I'll have 10 different people measure that table. Person 1 might be right on. Person 2 might be low. Person 3 might be high. Everybody's going to get a little bit different because we all might use that ruler slightly different. We might read it a little different. We might line it up not as well. Maybe one person's ruler isn't made as good as another person's ruler, that kind of thing. So there's going to be some noise. There's going to be a spread in those measurements. And so precision says, well, how close are they? Are they really all over the place, spread right out? Or are you kind of grouped really tightly? It seems like a pretty close, tight, precise set of measurements. All right, so precision is the repeatability. All right, and I like to keep this figure in mind that I drew here of a bullseye. I think it illustrates perfectly accuracy versus precision. So in your first measurement here, the red dots, man, they're right in the center of the bullseye and they're closely grouped. That is both accurate and precise. And ideally, that's what all our measurements, we would like them to be, accurate and precise. Doesn't always work out that way, but that would be ideal. All right, the next bullseye here, they're all over the place, aren't they? All right, so I would not call that precise. No, not precise. Accurate? Well, even though not a single one of these actually hit the middle of my bullseye, if I kind of took all these collectively and said, well, what's kind of the average? If I kind of just zoomed in, what is the average, the center of that range kind of? It's pretty much dead on the bullseye. Right? So if I averaged all those measurements together, I'd look pretty good. I'd be very accurate. All right, so I would say that those measurements are accurate, but not precise. And truthfully, while this first figure is what we'd love to have typically, the second figure is probably more reasonable, but more like what we often get in the lab. Right? Because our measurements can only be so precise. There's always errors in our measurement. We'll talk more about that in lab. All right? There's always going to be some noise and some spread to them. But if we take enough of them, hopefully we'll have an equal bias to being a little high versus being a little low, and therefore the average will be pretty much dead on. All right. What about the third one? Well, they're grouped really tightly. They're precise, but the average of those dots, that's not even close to the bullseye. All right, so here's just a case where it's precise but not accurate. And I found my fourth one. They're spread out all over the place, and even the average is way off of this dead center. So this is when it's neither accurate nor precise. Now, we'll talk more about this in lab, but how do you control for these things? Well, let's talk first about the precision. How tightly grouped are they? The only way really to get at better precision is to have a better instrument that we're measuring it with. Right? A better one. If I, just gave you a very sloppy ruler and gave it, all these different people the different rulers and asked them to measure the length of something, might be all over the place. But if I gave a vernier caliper, something that really is well made, the measurements would probably be grouped a little tighter, right? Because you have a better instrument. And so precision can be, to some degree anyway, improved by using a good instrument. Right? Accuracy, how close are they? Well, again, taking lots of them and average together usually give us an accurate number, so long as the instrument is made correctly, as long as it's calibrated correctly. Right? So, I don't know if you remember the old scales where, if you wanted to weigh yourself, you'd have to turn that little dial on the side of the scale, make sure it's on 0 first before you step on it. If it's like, let's say you actually weigh 178, but if it was already turned up to 10 pounds before you stepped on it, you get on there to be 188 and be like 10 pounds too high. You say, wow, I gained weight. Well, it wasn't calibrated correctly in the first place, and so it wasn't accurate. It's actually 10 pounds bigger than being accurate, right? So making sure your instrument is calibrated correctly at the very beginning, that's one way to get at accuracy. The book has some data here I'd like to take a look at as an example. Here we're looking at volume of cough medicine delivered by a 10-ounce dispenser. Okay, so it's supposed to deliver 10 ounces, or in other words 296 milliliters. That would be the true value. That's what we're aiming at. That's what we want. 296 milliliters. Dispenser 1, what did it do? 283.3, 284, 283, 284, 284. Precise? Accurate? Well, these numbers are pretty close. I would definitely say that's precise. Right? Is it accurate? Well, the average of those looks like it's going to be about 284-ish. It should be 296. Now that sounds like it's quite a bit off. So I'd say this is precise but not accurate. Those dispensers were not calibrated correctly. That number 1 dispenser. What about dispenser number 2? 298, 294, 96, 97, 93. These are spread out a little bit more. I wouldn't call those very precise, but 296 is what we're aiming at. 298 is a little above it. This one's a little below it. This one is basically on. This one's a little above. This one's below. It looks like I have kind of even bias as I'm going a little high or a little low. So the average of those numbers be very close to 296. And so these are not precise, but it is an accurate measurement, those set. Dispenser number 3, 296, 295, 296, 296, 296, very precise and right on, very accurate as well. So again, that might be the ideal sort of a case that we would want to get. Okay, so accuracy and precision. There is a difference. Make sure you know it.